So, let us have some interactive problem solving sessions by students who have taken this course. So, you will see some illustrations and examples into problem solving which is useful to understand and digest the concepts learnt during the lectures.
My name is Prayag, PhD student at IIC. I am going to solve a problem which is actually a final exam problem in the MMTSB course offered at IIC in the year 2017. So, the problem statement is as follows. If a signal S1 of t is integrable over a bounded interval, then prove that the integral of S1 of t over any interval of duration t does not depend on that particular interval given the signal S1 of t is periodic with period t. So, let us go over this problem statement again and extract all the given data. First point. So, the problem says a signal S1 of t is integrable over a bounded interval. So, mathematically this statement is the following: signal S1 of t is integrable over the interval a b, that means the integral S1 of t from a to b is less than infinity, where a and b are two real numbers such that a is less than b. That is the meaning of the statement. Second point is that signal S1 of t is periodic with period t. That means S1 of t plus or minus capital T is S1 of t for all t. Okay. So, let us look at what we have to prove. So, we have to prove that the signal, the integral of S1 of t over any interval of duration t does not depend on that particular interval. So, mathematically, so this is what we have to prove. Mathematically what it means is the following: integral of S1 of t over any interval of duration capital T. So, the duration of this interval is capital T, should not depend on the location of this interval on the real line. That means, this integral should be equal to integral of S1 of t from d to d plus t should be same as integral S1 of t from 0 to t, where c and d are any two real numbers such that c may not be equal to d. You can consider c equal to d, but it will be same. So, this is what we have to prove. So, let us understand the point number 3 pictorially, what it means. Since S1 of t is a periodic signal with period capital T, we have this. So, for example, to understand, let us consider a periodic signal. For simplicity, I am considering a cosine. I will make 3 copies of it. So, this is the 0 point, this is the time axis, this is S1 of t. So, the cosine signal is a periodic signal which extends from minus infinity to plus infinity. Like this. Now, consider the term integral c to c plus t S1 of t dt. Let us understand what this integral means. Now, take any point C and take another point which is C plus T. So, and the signal is periodic with period T, that means the capital T is here. Now, the integral the meaning is the area under this curve from C to C plus T. Okay. Let us call the area under this curve as A0. Similarly, consider the integral d to d plus t S1 of t dt. That means you consider any point on the real line and call it as t, and the other point d plus t. The meaning of this integral is again area under the curve from d to d plus t. Let us call this area as A1. Similarly, the integral 0 to capital T S1 of t dt is the area under the curve from 0 to capital T. Let us call this area as A2. Okay. What we have to prove is that we have to prove that A0 is equal to A1 is equal to A2. For this, consider the term C to C plus t S1 of t dt, which can be written as the running variable is t. So, C to capital T S1 of t dt plus t is equal to capital T to t plus c S1 of t dt. Let us call this term as T1 and this term as T2. Consider the term T2, that is T to capital T T plus c S1 of t dt. Now, define another variable m as t minus t. Now, when t is equal to small capital T, m is 0, and when small t is capital T plus c, m is c, and dm is dt. Now, with this new variable m, this integral becomes m 0 to c S1 of t. In place of small t, we can write m plus capital T. Okay. And in the problem statement, it says S1 of t is a periodic signal with period t, right. So, the integral becomes since m is a dummy variable, we can replace m by small t. So, therefore, this integral is t 0 to c S1 of t dt. Okay. Now, the term T2 is this. Now, let us call this equation as 1, and equation 1 which is nothing but integral 0 to capital T S1 of t dt. So, we have proved A0 is equal to A1 is equal to A2.